Hello, everyone. So I didn't get to completing the unit circle today and kind of constructing the whole thing. So I wanted to make a video to help you with that. Now, the unit circle is going to be um, kind of a quick way to find trig values, especially the big three, sine, cosine, and tangent, of any angle on the entire circle that has 30 degrees, 60 degrees, or 45 degrees as a reference angle. Um, it's going to help us find trig function values quickly and easily. So what is a unit circle? Really, the word unit circle in math just means a circle with radius 1. And so basically any radius you have, any length from the center out, all of this is going to be 1. It doesn't matter where on the circle you are, your radius is 1. Now, any of these points on our unit circle here, again, that's going to be an ordered pair x, y in space. And we know from Wednesday's class that to find the trig functions when you have an ordered pair xy on the terminal side of your angle theta, you can do the sine of theta is y over r. The cosine of theta is x over r. And the tangent of theta is y over x. Now, when we're on the unit circle, our radius is 1. And when you draw your triangle, so all of these radii are 1, right? Doesn't matter where we are. So if this is the point on our ordered pair, to find the trig values of our angle theta here, we will draw an altitude down and we'll use this triangle. Now, we called our hypotenuse r when we did this on Thursday, but we didn't really talk about why. And that's because this hypotenuse is going to end up being the radius of a circle out in space like this. When you fix a radius, you get a circle. And specifically in our case, this hypotenuse, this r value, is going to be 1 everywhere. And so when we come back to these guys, the sine value is going to be our y value of our ordered pair over r, but r is 1. So y divided by 1 is just y. That means the sine of theta is y. The cosine is x over r, but on the unit circle, r is 1. That means the cosine of our angle theta is just x. And the tangent of theta is still going to be y divided by x. Again, your angle theta is always going to be in standard position, and we are going to assume positive angle rotation. So this is how we find trig values out in space when you have an ordered pair on your terminal side. The thing about the unit circle is that we are going to kind of use this to kind of be a summary of everything that we've done so far for a lot of different angles. Okay, so these red dots around are ordered pairs on the unit circle. I'm going to go ahead and start filling in angles in standard position. So here, this is 0 degrees or 0 radians. And then as we come up, this point here is going to be 30 degrees. And as we know, that is pi over 6 radians. This one is 45 degrees, which is pi over 4 radians. And this guy up here is 60 degrees or pi over 3 radians. Up here, this is 90 degrees or pi over 2 radians. And then from here, it gets a little harder. So all of these that we filled in so far, these are the ones that I definitely want you to memorize. I don't want you to make a note card with these on it and make sure that you study these. And while we are memorizing things, I also want you to add these guys. That 180 degrees is pi radians is over here on the left side. And here on the bottom, this is 270 degrees or 3 pi over 2 radians. And then if we make it full circle, we'll come back to the origin. This ordered pair is also 360 degrees or 2 pi radians. 0 degrees and 360 degrees coterminal. So the same point works for both. That's kind of our beginning and our end of this circle. So both of these apply to this same point. So all of the ones that I have on here right now, these are the ones that I want you to memorize. Have them on the edge of your mind all the time. Put them on a note card anytime you are in line at Chick-fil-A or at a, I don't know, you're hanging out waiting for a friend to meet you somewhere. Anytime that you would kind of be sitting there and you want to pull your phone out to kind of scroll to kill some time, before you go to your phone, I want you to put these things on a note card, look at your note card, look through everything, quiz yourself on these, then you can look at your phone. That's kind of how I want you to look at these. Take a minute, I don't know, 3 to 5 times a day, and you'll have these memorized in a couple of days. So these are the ones I want you to commit to memory, and I want you to have them on the edge of your brain. Now, the rest of these, we can kind of start to figure out. So we're going to use, I guess, our knowledge to help us. So just like the distance between these 2 points, this is 30 degrees. The distance between these 2 points are going to be 30 degrees. We're going to use those reflections to help us. So 90 plus 30 degrees, this is going to be 120 degrees. From here to here, these guys are 15 degrees each. So this is going to be 135 degrees. And that means this will be 150 degrees. And that'll make sense because another 30 degrees here would connect us to 180, and that all works out. And we're going to use that pattern to fill in the rest of our degrees. So this is 30 degrees, so I'm going to add 30 to 180, and this is 210 degrees. This is 15 degrees here, so that makes this total 225. Add another 15, and we are at 240 degrees. And then this 30 brings us to 270. We'll keep going. 30 degrees here makes us at 300 degrees here. 15 degrees makes this 315 degrees. An extra 15 makes this 330. And this 30 degrees brings us back to 360 full circle. So that's how we get our degree measurements all the way around. And to get our radian measures, what I want you to do is use reference angles and some tricks to help us. Now, this triangle here, this is the same angle size as this one right here. So this angle of 30 degrees and this angle of 150 degrees have the same reference angle. Because they have the same reference angle, their radian measures are going to have the same denominator. So I know this is going to be a number over 6, and there's going to be a pi on top. I just have to figure out what number goes with it. Similarly, this 135, this has the same reference angle as 45 degrees. So I know that's going to have a pi over 4. It's going to have the same denominator. And then this 120 degrees is a reflection of 60 degrees. They have the same reference angle. So I know this is going to be some kind of pi over 3. Now, in my second quadrant here, my radian measures, these are going to be almost 1 pi. So if I have something pi over 3, this is actually 2 pi over 3. 135 degrees is 3 pi over 4, and 150 degrees is, let me think about this, it's almost 1, so it's 5 pi over 6. So again, everything in this first quadrant, my radian measures are almost 1 pi. 120 is 2/3 pi. 135 degrees is 3/4 pi. 150 degrees is 5/6 pi. All of these fractions are almost 1 pi. Your numerator is 1 less than your denominator. And then in quadrant 2, again, we're going to look at reference angles. So 210 degrees, this angle here, this matches the angle that we had from 150 degrees, which matched our 30 degrees. This is a 30-degree reference angle. This is going to be something pi over 6 because my reference angle here comes from here. My denominator and my radians is going to be the same. In 225, my reference angle here is 45 degrees or pi over 4. So my radian measure is going to be something pi over 4. And my 240 degrees, my reference angle, this has the same reference angle as pi over 3. So I know this is going to be something pi over 3. Now, in quadrant 3, all of these measures down here, oops, sorry, it's not almost, just kidding. My brain's not working. These are going to be a little bigger than 1 pi. They're just a little bit bigger than 1. So 210 is 7 pi over 6, 225 is 5 pi over 4, and 240 is 4 pi over 3. All of these fractions are a little bit bigger than 1 pi. 7/6 pi, that's a little bigger than 1. 5/4 pi, that's a little bit bigger than 1 pi. And 4/3 pi is a little bit bigger than 1 pi. Your top is going to be your bottom plus 1. So 7 pi over 6, 5 pi over 4, 4 pi over 3. That number on top is 1 larger than the number on the bottom. And again, our last quadrant down here in quadrant 4, let's start with 300 degrees. Our reference angle here, this is going to match the reference angle up here at 60 degrees. So I know my reference angle here is 60 degrees. This is going to be something pi over 3. 315 degrees, that has a reference angle of 45 degrees. So I know this is going to be something pi over 4. And 330 degrees, that has a reference angle of 30 degrees. This is going to be something pi over 6. Now, in quadrant 4, our radian measures are going to be almost 2 pi. So let me run through these. 300 degrees is 5 pi over 3. 315 degrees is 7 pi over 4. And 330 degrees is 11 pi over 6. These are all almost 2. 5/3 pi, that's almost 2 because 2 pi would be 6/3 pi. That's almost 2. 7/4 pi, 8/4 pi would be 2 pi. So this is almost 2. And 11 pi over 6, 11/6 pi, that's almost 2 pi because 2 pi would be 12 pi over 6. So here, the top is going to be the bottom times 2 minus 1. The number on top is going to be 1 less than twice the bottom. 11 is 6 times 2, 12 minus 1. 7 is 4 times 2, 8 minus 1. And 5 is 3 times 2 minus 1. These are almost 2. So that's kind of the links to make with the reference angles and how to fill in your radian measures around your unit circle. Those are the connections that I want you to make. Now, the ordered pairs on our unit circle, we're going to label the ordered pairs that go with each of these points. I'm going to start with our quadrantal angles. What that means are these angles here between our quadrants. These are the ones on our axes, because these are going to make the most sense. So this point over here, this is the point 1, 0. That's an ordered pair on a circle of radius 1 centered at the origin. Up here at 90 degrees, this is the point 0, 1. Over here at 180 degrees, this is the point -1, 0. And down here at 270 degrees, this is the ordered pair 0, -1. Now, to get all of the other ordered pairs here, we're going to have to think about this a little bit. The x value in each of these ordered pairs is going to be the cosine of the angle that has the terminal side that goes through that point. So here at 30 degrees, this is our angle theta, and the ordered pair that goes along with this is basically going to be the cosine of 30 degrees and the sine of 30 degrees, because our x value is the cosine of theta and our y value is the sine of theta. So x is cosine, y is sine. So to figure out what those values are, we have our triangles for right now. So we'll do our 45, 45, 90. So we've got root 2, and 2. And we have our 30, 60, 90. That's a 60 degrees. And this is 30 degrees. And this is 1, 2, square root of 3. So if I look at my triangles here, the cosine of 30 degrees, I'm going to look at this angle here, the cosine of 30 degrees is going to be adjacent over hypotenuse, square root of 3 over 2. So I'm going to replace this with the square root of 3 over 2. That is the x coordinate here at 30 degrees. The y coordinate is going to be the sine of 30 degrees. So again, I'm going to look up here at my 30-degree angle. The sine of 30 degrees is opposite, which is 1, over the hypotenuse, which is 2. The sine of 30 degrees is 1/2. So this is the ordered pair associated with 30 degrees. And again, our x value is the cosine of our angle, and our sine value, or our y coordinate, sorry, is the sine value of our angle. That's what these ordered pairs represent. And that's how we're going to find the 3 in the first quadrant. Now, here at 45 degrees, the ordered pair that goes along with this one, our x value is going to be the cosine of 45 degrees. If I come up here and look at a 45-degree angle, cosine is adjacent over hypotenuse. That's the square root of 2 over 2. And our y value is the sine of 45 degrees. Sine of 45 degrees is opposite over hypotenuse, square root of 2 over 2. At 60 degrees, the ordered pair that goes along with this is going to be the cosine of 60 degrees. So here I'm going to look at my 60-degree angle. Cosine is adjacent over hypotenuse. That's 1/2. And the y value is the sine of 60 degrees. The sine of 60 degrees is opposite over hypotenuse. That is the square root of 3 over 2. So these are the ordered pairs that go along with each of our angles here. The ordered pair at 30 degrees is root 3 over 2, 1/2. The ordered pair at 45 degrees is root 2 over 2, root 2 over 2. And the ordered pair at 60 degrees is 1/2 root 3 over 2. Now to get the ordered pairs in each of our other quadrants, we're just going to use the fact that, well, the trig values for 120 degrees are 2 pi over 3. The trig values here are going to match the trig values of our reference angles. It just might change to be positive or negative. Here in quadrant 2, we know all students take calculus. Sine is the only one that's positive, and the other two are negative. That means sine is our y values. Our y values are going to stay positive. Our x values are going to go negative. Since 2 pi over 3 has a reference angle of pi over 3, I'm going to have the same values as I did over there, 1/2 root 3 over 2. But I have to make sure that my y value is positive and my x value is negative. So I'm going to make my x value negative here. The cosine is negative in quadrant 2. And I'll do the same here. 135 degrees, or 3 pi over 4, that is a reference angle of pi over 4, which means my values here, my trig values, are going to match root 2 over 2, root 2 over 2. But because we're in quadrant 2, the sine, my y value, will stay positive, but my cosine, my x value, needs to go negative. Similarly, at 5 pi over 6, this ordered pair is going to match the values at pi over 6, which is root 3 over 2, 1/2. Our y value is going to stay positive because the sine is positive here. Our x value is going to go negative because the cosine is negative in quadrant 2. Okay, and then we're just going to use this process to fill in the rest of these. So at 7 pi over 6, our reference angle is pi over 6. So our values are going to be the same as here at pi over 6. So it's going to be root 3 over 2, 1/2. But now I'm in quadrant 3. All students take calculus. That means tangent's positive, but everything else is negative. That means both sine and cosine, sorry, sine is your 1/2, so both sine and cosine are negative here. 5 pi over 4, that is a reference angle of pi over 4, so my values here are going to match my reference angle. So it's going to be root 2 over 2, root 2 over 2, but sine is negative and cosine is negative here in quadrant 3. And at 4 pi over 3, these values are going to match my reference angle of pi over 3. Values will be the same, 1/2 root 3 over 2, but my sine is negative and my cosine is negative in quadrant 3. Finally, we're doing quadrant 4. And again, we're just going to use reference angles. So 5 pi over 3, that is a reference angle of pi over 3. Our values will be the same, 1/2 root 3 over 2. But in quadrant 4, all students take calculus, which means cosine is going to be positive. Everything else will be negative. Cosine is my x value. That will stay positive. But my sine, which is my y value, has to go negative. At 7 pi over 4, this is going to match my reference angle of pi over 4. So this is going to be root 2 over 2, root 2 over 2. Cosine stays positive, sine goes negative. And here at 11 pi over 6, our ordered pair here is going to match our reference angle of pi over 6. So I'm going to have root 3 over 2, 1/2. My cosine will stay positive and my sine goes negative. This is the unit circle. So it's a lot of information inside one tool. And there's a lot of information coded in here as long as we know how to use it. So let's practice using this. And again, all of these ordered pairs are going to help us quickly and easily grab trig values of any of these angles that appear on our unit circle. Again, y is our sine value and x is my cosine value. If you need to calculate a tangent value, that's not directly on the unit circle, but remember, tangent is y over x. Okay, and I know this unit circle is a little messy because I'm trying to fit so much other information here to help you figure out where all of this came from. You can always get a clean unit circle from the internet, and I'll show you on D2L. I also put a blank unit circle for you to practice filling in the blank class notes content folder. I'm going to go through that with you on Monday so that you can practice filling this in and get really confident in your ability to fill this in and get all the values on here quickly and accurately. Okay, so how do we use this? Okay, so here it says find the terminal point on the unit circle determined by 5 pi over 6. The terminal point on the unit circle, that means the ordered pair that's on the terminal side of the angle 5 pi over 6. So I'm going to come up to my unit circle. 5 pi over 6, this is a little bit smaller than 1 because 5/6 is less than 1. 1 would be 6/6. Because this is less than 1, I'm in quadrant 2. So I'm going to look in quadrant 2. Here's 5 pi over 6. The terminal point, or the point on our terminal side, is negative root 3 over 2, 1/2. And again, these came from the fact that our reference angle for 5 pi over 6 was pi over 6. And because we are in quadrant 2, that meant that our cosine value was negative and our sine value is positive here. And these values, root 3 over 2 and 1/2, those came from the cosine and sine values of pi over 6, 30 degrees. All right, now, number 2, find the exact value of cosine of 3 pi over 4. Okay, 3 pi over 4, that's an angle on the unit circle. And 3 pi over 4. 3/4 is a little smaller than 1, right? Because 1 would be 4/4. So 3 pi over 4 is a little smaller than 1 pi. That means this is going to be in quadrant 2 again. Here's 3 pi over 4 right here. I'm going to use the ordered pair um, on my unit circle, and I wanted the cosine value of 3 pi over 4. The cosine is your x coordinate. So the cosine of 3 pi over 4 is the x coordinate here, which is negative root 2 over 2. So that's how the unit circle is going to help us quickly grab the values of trig functions for these angles. All right, next one. Find the exact value of the tangent of 4 pi over 3. Okay, 4 pi over 3. 4 over 3 is a little bit larger than 1. 1 would be 3 over 3. So I know this is going to be in quadrant 3. 4 pi over 3 is right here. And I want the tangent of 4 pi over 3. Well, I'm not sure. Tangent's not on the unit circle. X is cosine, y is sine, but I need tangent. Well, to find tangent, we are going to do y divided by x. That still applies here. So I'm going to do my y value of negative root 3 over 2. And I'm going to divide by my x value of negative 1/2. So the tangent of 4 pi over 3 is the y value divided by the x value at 4 pi over 3. And my brain just left me here. This is going to be negative root 3 over 2 over negative 1/2. And I can't leave fractions within fractions. I need to simplify this. To do that, I'm going to keep the top, change this division to multiplication, and I'm going to multiply by the reciprocal of the bottom. My 2's cancel, my negatives cancel, and I get root 3 over 1, which is the square root of 3. That is the exact value of the tangent of 4 pi over 3. If you put the tangent of 4 pi over 3 in your calculator, you're going to get a decimal approximation, and it's going to be real hard to work your way back to the exact value of the square root of 3. I'm going to want exact values. I will not take decimal approximations from your calculator, just punching in these values. that's not going to work for me. Just kind of a heads up. All right, last one in this kind of section here. Suppose x, 3/5, is a point lying on the unit circle in quadrant 2. Find x. Okay, well, unit circle, and it's in quadrant 2. So the unit circle has a radius of 1, and we're over here in quadrant 2 somewhere. This is x 3/5. Now I know that, let me in my terminal side here. I know that when I'm working with an ordered pair on the terminal side of an angle, I know that my hypotenuse here is r, and that r squared equals x squared plus y squared. Because this is the unit circle, I know that r is 1, so that I know 1 squared is equal to my x coordinate, which here stays x, plus my y coordinate, which here is 3/5 squared. This comes from something that we did on Wednesday. It's just the Pythagorean theorem, because if you drop your altitude down, this side is x, this side is y, which is 3/5, and on the unit circle, r is 1. And so we're basically just doing the Pythagorean theorem here to figure out what x is. Okay, so now to solve this, 1 is equal to x squared plus 9 over 25. I'm going to subtract 9 over 25 from both sides to get to x squared. So this is 25 over 25 minus 9 over 25. I come up here. 25 over 25 minus 9 over 25 is 16 over 25. Subtract your numerators, keep your common denominator. We're going to take the square root of both sides, and that means x is then going to be plus or minus 4/5. Because again, we're not in quadrant 1, so we got to be careful with the plus or minus. Is x going to be positive or negative here? Well, we're in quadrant 2. This x value is negative in quadrant 2. So I'm going to take the negative value here. So x is going to be negative 4/5. And again, that negative is because we're in quadrant 2 and x values are negative in quadrant 2. So the unit circle applies to more than just our special angles. When we memorize the unit circle, these are the angles that are going to be on the unit circle. And so these are the angles that we're going to use the unit circle for the rest of the course. But the idea of the unit circle and how it works apply to any triangle that you would like. But really the biggest thing is that the unit circle means that your radius is 1. Okay, and then I just want to go through this last one quickly with you. Most of you will just plug this value in and it'll be just fine. So to do part A here, that's going to be 2 times the cosine of theta. And here we have theta is 4 pi over 3. So to do this, you're going to figure out what the cosine of 4 pi over 3 is and multiply it by 2. If I come back up to my unit circle, the cosine of 4 pi over 3, 4 pi over 3 is down here in quadrant 3. The cosine of 4 pi over 3 is my x value here of negative 1/2. And so our cosine value here is negative 1/2. And I'm going to multiply that by 2. So overall, I get negative 1 out of this. You'll just evaluate the cosine of your angle and then multiply by 2. This next one, the notation here, if you see cosine squared, I know it's kind of strange to put the 2 here, but that's just to differentiate whether you are going to take the cosine of your angle and then square that whole cosine value, or whether you're going to square the angle and then plug that squared angle into your cosine. The 2 goes here because we're squaring the whole cosine value. This notation means the cosine of theta, that whole thing squared. And so we're first going to take the cosine of our angle theta, which is 4 pi over 3, and we're going to square it. So the cosine of 4 pi over 3, we just did that. That's -1/2. When we square that, -1/2 times itself gives us a positive 1/4. That's the value that we would get out of this guy. And then this last one, part C, this is asking for the cosine of theta over 2. That means we're going to take our angle theta, divide by 2, and then plug that whole thing into the cosine function. So we're going to do the cosine of 4 pi over 3 all over 2. So we need to simplify here inside the parentheses to figure out the angle that we're going to take the cosine of. So we're going to keep the top, 4 pi over 3, change this division to multiplication, and multiply by the reciprocal of the bottom. The bottom's 2 over 1, so the reciprocal of that is 1/2. This 2 will cancel with the 4, and inside we are going to simplify to 2 pi over 3. So overall, this is asking me for the cosine of 2 pi over 3. 2 pi over 3, that's an angle on my unit circle. I'm going to come up here to my unit circle. 2 pi over 3 is right up here. And I wanted the cosine value, so I'm going to look at the x coordinate here, -1/2. Okay, so that is the unit circle and how to use it. Um, so for now, I want you to work on figuring out where all of these values come from on the unit circle and how to use it. Um, and then we'll talk on Monday about memorization techniques and how to commit this to memory so that you can reproduce this quickly and easily on an exam and use it to your advantage. So, um, right now, focus on the unit circle and what it means. And then I will see you on Monday for more trig. Have a great weekend. Spend some time with homework 5. Really think about some of these things and start making connections. There's a lot of really important material in here that serves as the basis for the rest of this course. So have a great time, enjoy, and I will see you on Monday.